encoder, decoder, multiplexer, half adder, full adder, half subtractor, different type of thing, comparator. So after that, whatever you can say, what are the outputs are producing, and based on the input and output, how transaction timing diagram is behave, like that particular circuit is how it is behave. Okay, all the parts you can say. Okay, so this is the not a level. Just I'm giving some particular hint to you. So that is the no problem. So where is my slide? Ready? Where is the other slide? This one we are already discussed or not? This particular slide?
Yes, sir. Yes, sir.
Maybe some particular slides are missing. Okay, no problem. How it is coming? Where is the other slide? Maybe something happened because after that, what happened when I'm designing this? When I'm building the slide, that means when I'm making the slide, that time I left this particular laptop and my mic is doing something wrong with this. Okay, no problem. So last class we are discussing about the combinational circuit. Okay, hope all of you are getting actually whatever we are discussing till now. Okay. Again, whatever we are conducting some particular tutorial class or any particular class, you have to ask, because when we are going to the sequential circuit, then if you are asking about the combinational circuit, then it is difficult. That means again I'm going to the backward direction. So instead of that, if you have any doubt when I'm discussing some particular topic or unit, that time whatever it is better you can ask if you are getting some particular problem within that particular during the class. Okay. So already we are discussing many things. What is the behavior of the combinational circuit, and which type of circuit is called a combinational circuit? Suppose like example half adder, full adder, and how adders are working in parallel. Why without using the subtractor, how we can use the adder circuit? Okay, all of those things we are already discussed. Okay. So last class we are we are discussing about the multiplexer. So multiplexer, you know, that means always what happen? It is 2 to the power n minus 1 into 1. Okay. And if we are, how we can get the selection line? If suppose what happen here, suppose in this particular example, if I'm using the 4 into 1 marks, that time what happen? 2 to the power 2. This particular 2 is considered as a selection line. Are you getting my point? And otherwise, what happen? How we can use this one? This one is 2 to the power. Generally, what happen? 2 to the power n minus 1 to 1 marks. Okay, if it is 3 variable, that time what happen? 3 minus 1, it is 4. This way we can minus 1. Maybe this one is the minus 1. Okay, 2 to 1 marks. 2 to the power n minus 1 into 1 mark. Suppose what happen? Here if we are using 4 marks, that time what happen? This particular 2 to the power square 4 minus 1. No, this one is not required. I think this 2 to the power n minus 1 to 2 to 1 is the marks. Okay. So now how we are, suppose this one is the 4 to 1 marks. Okay. So we are constructing 4 to 1 marks using 2 to 1 marks. Okay. So what is 4 into 1 marks? 4 into 1 marks means what? Suppose always marks means what? Multiplexer. Shortly we are saying that this one is marks. Okay. This one is the output. Always output is only 1. Okay, and suppose what happen if we are using 4 to 1 marks, that time what happen? So this one is particular 1, 2, 4 lines are there. Okay, so D0 to, suppose D0 here, this one is the D0, here this one is the D1, so up to D3. Okay, so according to the properties of multiplexer, so if we are using the 4 into 1 marks, that time what happen? Only there are, but there are 2 selection line or control line. So it's called select line. Okay, because 2 to the power n means what? N is the number of selection line. So here we are using 4 into 1 marks. Okay, 4 into 1 marks. That for a particular purpose, what happen? We are using only 2 selection line. Okay, based on the selection line, automatically what happen? This particular line, maybe it is propagated to the output. This particular line is propagated to the output based on the selection line or any of the lines of the data lines. Okay. So maybe D0, maybe D1, maybe D2, or maybe D3. Now what happens when you are encountered this type of things, 4 into 1 marks using 2 into 1 marks, always remember, that means what? Our main objective is that we are constructing 4 to 1 marks. But we cannot directly apply 4 into 1 marks. So what happens? Here it is, we are using only 2 to 1 marks. So 2 to 1 marks means what? Data line is always 2. So sorry, this one is the D1. And this one is the D2. Okay. So why we are using the 2 into 1 marks, that means 2 multiply, why we are using number of 2 numbers of 2 to 1 marks? Because what happen? We are constructing 4 to 1 marks. So 4 to 1 marks means what? Here D0 to D3. So if we are using only 1 marks, that time what happen? We are going only D0 to D1, but we cannot provide the D2 and D3. So satisfy that particular condition, we are using 2 marks, this one and this one. So always, now you already know, if we are using 2 to 1 marks, that time what happens? Selection line is only 1. Are you getting my point? And output is always, all the multiplexer have only one output. Okay, this is the properties of multiplexer. Now see how this particular multiplexer actually using. So it is similar to the, or it is producing the same function for 4 to 1 marks. Okay, so see here maybe what happened, based on this particular selection line, that time what happened, we can check that which multiplexer is working. This particular multiplexer is working, or this particular multiplexer is working. Okay, so for that particular purpose, what happened, based on the selection line, here 2 lines are there. It is A, we are giving the name of A and B. You can take any name, okay, X, Y, or whatever, S0 or S1, it is no problem. So see here, if B0 is 0, that time what happened, this particular information provided that if B equal to 0, that time what happened, automatically this particular multiplexer is working. So no need to check this particular multiplexer, because what happened, the B is providing the 0. So when B is providing the 0, then this particular line is automatically connected to 2 to 1 marks. Are you getting my point? And after that, what happened? There are 2 lines, D0 and D1. So what happened, based on A, that means if A equal to 0, that time what happened, this particular D0 is propagated to Y. And this particular Y means what? It is connected with this particular 0. And output is propagated to here Y. So what happened? Y, if B equal to 0 and A equal to 0, Y equal to D0. And D0 belongs to this particular first marks. Okay. So when we are computing that one based on this particular signal, that means automatically what happens, circuit is not working with this 2 to 1 mux. That is the beauty of multiplex. Suppose what happen if b equal to 0, but what happen this particular mux is selecting as a, that means a equal to 1, control line is 1. Okay, earlier control line is a is 0, but what happen now it is a equal to 1. That time what happen, we are not selecting d0, we are selecting as a d1, and d1 is connected to this way, this one, and this particular one is connected to y. Okay, so for that particular reason I am writing this particular combination of selection line 0 and 1, where b equal to 0 and a equal to 1, y equal to d1. Similar case, when b equal to 1, that time what happen, earlier what happened, when it b equal to 0, that time what happened, this particular mux is connected to first mux. Now when b equal to 1, that time what happened, this particular mux is not working. Now what happened, this particular mux is working. Are you getting my point? So that time what happened, if it is 0, that time what happened, d2 is selected and it is propagated to y. But what happened if b equal to 1 and a equal to 1, that time what happened, d3 is propagated to y, and again y is connected to this one and this one is produced. So this way we can construct the 4 into 1 mux using 2 into 1 mux. So same thing, if you are applying 8 into 1 mux using 4 into 1 mux, can you tell me how many mux we are using? So if your idea is clear, this one, suppose what happen, now implement a 8 to 1 mux using 4 to 1 mux. Then you can tell me how many mux we are using.
Sir, 2, 4 to 1 mux.
4 to
4 to 1 mux. We can use 2, 4 to 1 mux.
Yes. So suppose yes, suppose what happen is that means we are implementing 8 to 1 mux, but using 4 to 1 mux. So 4 to 1 mux, how many you are telling? How many 4 to 1 mux we are using?
2.
Yeah, 2. 2. Anyone? Okay, someone is saying that. What is your name?
Tamalika.
Tamalika. You are saying that we are using two number of 4 to 1 mux we are using. So anyone have some other answer?
Sir, can you repeat once?
Suppose we are implementing, we want to implement 8 to 1 mux using 4 to 1 mux. So my question is that how many 4 to 1 mux we are using to implement a 8 to 1 mux? How many number of 4 to 1 mux we are using?
Sir, we can use 2.
We can use 2. Okay, no problem. Suppose we are going to start 2 marks. Okay, no problem. Yes, very good. You are saying that 2. Tamalika also saying that it is 2. Okay, no problem. Suppose we can check. This one is 4 to 1 marks. So it is taking some time. You be patient, huh? Because my drawing is very. I'm not. Yeah. So 4. Suppose here I am using. Okay, no problem. No problem. This one is D0. And you can write here D1, D1, D2, and D3. And here, because it is 4 into 1 marks, obviously here what happened? I am using this one. Suppose I am giving this one is the selection line S1 and S0. No problem. So output is always 1. This is the 1 marks. Okay. Or to 1 marks. This one is S1. This one is S0. No problem. So this one is what? D4, D5. Yes or no?
Yes, sir.
D6. And the last one is D7. Okay, no problem. D7. This one is D7. Now you are saying that when we are using the 8 into 1 marks, that time what happened? The number of 4 into 1 marks is 2. Okay, we are constructing the 2 4 into 1 marks. Now can you tell me or can you suggest me then how we can construct the 8 into 1 marks? 8 to 1 marks.
Sir, the number will be 4. We need 4 into 1 marks.
We need four number of 4 into 1 marks.
Sir, I
Yes,
think
sir.
we need 3.
So see, your concept is still now it is not clear because see here, someone is saying that 2, someone is saying that 4. So obviously whatever we are using this particular structure. We are using the same structure. So if we are using only 4 into 1 marks, then how we can construct the 8 to 1 marks? Because see here, if we are using only 2 into 1 marks, number of 2 number of 4 into 1 marks, that time what happened? This one is Y and this one is Y. Then how you could suppose I want to select the data line 7, D7. So then how we can enable this particular second 4 into 1 marks?
Sir,
Okay.
we need 3 4 into 1 marks.
Then why you are telling that? Yes.
Yeah.
Why you are telling that we are using only the 4 into 1 marks? Okay.
Sir, 2 for the variable A and then 1 for the variable B. I think so.
Any other? Anyone? Anyone? So okay, a lot of confusing are there. So you can please write the homework. This one, implement A. I am not discussing this one. You can try at your home because we are using the same structure. Concept is same. Whatever we are discussing for 4 to 1 marks. Are you getting my point? So you can try this one. Implement A 8 to 1 marks using 4 to 1 marks. Is it possible or not? You can try at your home. Okay, suppose what happened here, this particular case, what happened? This one is okay. This one is okay. We can satisfy. But what about this one? This one is okay or not? So if we are using only 4 into 1 marks here, that time what happened? Is it correct or wrong? Because what happened here, we are using only what happened, how many data inputs lines we are using only 2. But what happened according to the when we are using the 4 into 1 marks, it is must be 4. Yes or no? So what about the other 2 lines? When we are where we are getting these particular 2 lines, input lines. And if you are increasing the 4 into 1 marks, that time what happened? It is going to the D0 to D15. Okay, but we are interested to construct only 8 to 1 marks. Okay, so how we can solve this one? Can you give some particular year? If you are how we can construct this one? So that means my question is correct or wrong? So 8 into 1 marks using 4 to 1 marks, is it possible or not?
Not there.
Huh? say something?
Sir, might be possible.
How?
Sir, if we sir, here the structure is fine. We just need two more inputs for the last 4 into 1 marks. So if we take two more 4 into 1 marks, and the output will go to the last one, so then we can get 4 inputs for the last one.
So that is my question. So where we are collecting the other two inputs, how we can insert the third 4 into 1 marks? Where we are getting that
Yes, sir.
particular rest of the two inputs?
Sir, by implementing another two 4 into 1 marks.
So when yes, that is also yes. But if we are using another two 4 into 1 marks, that time what happen? That input lines is going to D0 to D15.
Yes,
But
sir.
our main objective is that we are constructing 8 to 1 marks. So when we are
Yes, sir.
going to construct 8 to 1 marks, that time what happen? Our input lines, the range of the input lines is D0 to D7. We are not going beyond that.
Sir,
Yes.
sir, we can use two into 1 mark and 4 into 1 mark.
Yes. Tell me how two into. Okay.
Sir, we can use two into 1 marks
Hmm.
and 1
Okay.
4 into 1 marks. Then it will be 8, D0 to D7, and it will give 4 inputs.
Yes. Yes. That is also correct. Good. That means what? Easily we can construct. Yeah. This one. Just a minute. Where is the? This one we are not using 4 into 1 marks. Instead of 4 into 1 marks, if we are using 2 into 1 marks. Yes or no? You are saying like that?
No, sir. No, sir.
What?
I am telling to take two into 1 marks as an input and 1 4 into 1 marks, and then we can get 8 to 1 marks.
But question is saying that implement 4 to 1 marks using only 8 into 1 marks using only 4 into 1 marks. Then questioner restrict. Don't use the 2 into 1 marks. That means question is only mentioning that you have to implement the 8 into 1 marks using only 4 to 1 marks. That time.
Okay, sir. I check it again if I can find any other way.
So see here. So that is the one option, good option. See, instead of 4 into 1 marks, if we are using only 2 into 1 marks here. So this one we are using 4 into 1 marks. This one we are using 4 into 1 marks. It is okay, well, good. And after that, what happened? Third marks we are using instead of 4 into 1 marks, 2 into 1 marks. That time what happened? Maybe this one is 8 into 1 marks. So you can cross verification. You can check this one is correct or not. And what other possibilities are there? Okay, suppose question is that implement 4 to 8 into 1 marks using only 4 to 1 marks. That time what happened? This one is. Can we solve this way? So you can just think about this one. Okay, and tell me what is the alternative options are there. But what happened here? Suppose here I'm using this one is the S0 S1, and suppose what happened if I'm using 2 into 1 marks. That time what happened? This one is the S3. Because 2 into 1 marks means what? Only one particular selection line is there. So how many selection lines in this particular structure? In this particular structure, we are using 3 selection line. One is S1. You can S0. So suppose here I am using suppose S2, S2, S1, and here we are using suppose S0. Okay. So S0, S1, S2. Suppose here I am using S0 and S1 and S2. So how many combinations it is from? It is 2 to the power 3 means what? It is going to 0, 0 to what? 0, 0 to up to 1, 1, 1. Yes or no?
Yes, sir.
It is going up to 1, 1, 1. So this one is 1, this one is 1, and this one is 1. See here, this particular last one is the S0. So you know that means here how many zeros are occurred? 4 numbers of zeros are occurred, and in S0 variable there last 4 number of ones are occurred. So when 4 number of zeros are occurred, that time what happen? We are using the first marks. When S0 equal to 1, that time what happen? We are using the second marks. Okay, that means what? It is going D0 to D0 to D3 and D4 to D7. So if we are using first marks, that time what happen? Based on the S2 and S0, suppose S2 and S0 are 0, 0, that time what happen? D0 is propagated to this one. And here 2 to 1 marks means what? If we are using 2 to 1 marks, that time what happen? Only one particular output is there. We are not using any other output because what happen? This is the marks. Only one output is generated and D0 is propagated to this one. If we are using suppose S1 is 10, suppose 10, that time what happen? D2 is 0, 10 means what? 2. So 2 is propagated to this one. So this is the another, because we are using 4 into 1 marks and another is 2 to 1 marks. But question is especially mentioned that if we are using 4 to 1 marks, 8 to 1 marks, using only 4 to 1 marks, that is possible or not. You can just cross check and you can tell me the answer in the next class, or you can demonstrate me that this way, sir, this way we can do that one. Okay, it is homework for you. Okay, or if it is not possible, then why? You can tell me. Okay. So next one. So implement the logic function using marks. So how you can implement the logic function using marks? Okay, till now we are we are discussing how to construct the marks and what type of marks are there. So if we are using big marks, that time what happen? Some particular small marks we are using to construct the big marks. Okay, so this particular part we are already discussed. Now what happen? Again what happen? Some particular logic function also we are implement with the help of marks, but there are some particular certain type of rules are there, so we can follow that particular rule. And why this type of rules are coming? Okay, so suppose what happen? I'm using one particular example. With the help of example, I'm explaining how logic functions are actually implement with the help of marks. Okay, see here, we can realize the function. This is the function. Okay, what is the function? This one is the function, and this particular function is the short form because we are using the mean term symbol here. And if you are carefully from this particular mean term also, you are getting the expression. Okay, so if you are breaking this particular mean terms very carefully, that time what happen? You can get the expression, Boolean expression. Okay, so this particular function is there. Okay, so maybe this is the expression form, or maybe in the mean terms form. In this particular example, we are providing the mean terms form. If some particular expressions are there, then obviously you know how to, from the expression, how to convert to the mean terms or max terms. Okay, so suppose I am giving this way, and what happen? This particular function we are constructing with the help of 8 to 1 marks and 4 to 1 marks. Okay, good one. Now what happen? Based on this particular function, we are finding the behavior of this particular function. So when we are finding the behavior of the function, then always remember this particular part we can demonstrate it with the help of truth table. We are using truth table. Okay, so see here, in this particular function, how many variables are there? 3 variables. And when we are using the function, then always when we are using the marks, you remember always we are using only one output. Suppose I am considering this one is the output y, and based on this particular mean term, suppose I am using here, suppose another one. This one is not required, but I am using f for understanding purpose. This one is the f, small letter f, and this one is the ABC. A, B,
Hello. Are you hear me? Are you hear me?
Yes, bro.